Hello everyone, my name is Adam Tischler, and I'm here today to provide a short video tutorial on how to ship IP tables firewall logs from an Ubiquiti Unified Security Gateway appliance into an Elastic stack. I'll demonstrate how to compile and configure Filebeat, which is a lightweight log agent that is capable of running directly on the Ubiquiti firewall. In order to get the environment up and running with minimal effort and time, I decided to leverage Docker, which has containers officially supported by Elastic for running Elasticsearch and Kibana. We need to do a few other auxiliary tasks, so we'll put to use a CentOS Docker container. I'll make the assumption that you have Docker configured and running in your own environment. If you haven't installed Docker yet, you'll want to take care of that first before attempting to complete the process that I'm about to demonstrate. I'm running Docker on my Windows 10 host, but Docker can be run on many different platforms, which is one of the reasons why I enjoy using it so much. I'll start the process by running a new Elasticsearch Docker container. Elastic has easy to follow documentation, and I'm taking these Docker commands directly from it. We are starting the container with the appropriate ports exposed, and have also instructed it to set the discovery type configuration key to single node. If you're familiar with Elasticsearch, you will understand why this is required, but I can tell you that it has to do with the fact that we are running only one node in our cluster versus multiple nodes. We could have started the container in daemon mode, but it is nice to see the standard output as the container starts to confirm things are running properly. Once it looks like everything is going, I hit Ctrl+C to escape back into my Windows command prompt. Next, we need to run our Kibana container. Kibana is the front-end user interface for interacting with security analytics data, which is stored in Elasticsearch. When executing our docker run command, we expose port 5601 and create a Docker link between our Elasticsearch and Kibana containers. When creating that link, we need to reference the Elasticsearch container name or ID, which can be found in the output of the docker ps command. As with the Elasticsearch container, we run the Kibana container in interactive mode to watch the standard output and confirm that it is happily running and connected to Elasticsearch. From a web browser, I opened the Kibana page by typing in the IP of my Windows host, followed by a colon and 5601 to hit the correct port that Kibana is running on. Once in the Kibana web interface, I go to the Monitoring tab and enable Elasticsearch monitoring, which will be useful later in this process. Ctrl+C returns us back to the Windows terminal. Now it's time to spin up our CentOS Docker container, where we will compile Filebeat and configure it before using SCP to move the files over to our Ubiquiti USG. I used docker run-it to start an interactive terminal inside my CentOS container. I'll need git and wget to pull the files from the internet, so I install those packages and their dependencies with the yum install-y command. I move into the home directory and retrieve the Linux x86 version of Filebeat, which comes with the IP tables module and a sample config file. The binary that is included with these files is meant to run on an x86 architecture, but our Ubiquiti will not run it, so later we will grab the source and compile it for MIPS64, which is supported by our Ubiquiti firewall. I decompress the archive with the tar command and then move it into a more friendly named location. Next, I pull the Go language binary archive from the internet with the wget command and then decompress the archive and move it into the user local directory. After that, I set the Go root Go path, and path environment variables for my system. We can confirm that Go is installed properly by running the Go version command and confirming the output. I found a great guide for installing Go on CentOS that I'll link in the description of this video. Now it's time to pull the uncompiled source for Filebeat so we can compile it for our MIPS64 architecture that the Ubiquiti Firewall runs on. I make a local directory for the source code and then use the git clone command to clone it into that directory. After moving into that directory, I run the go build command with the appropriate switches to compile it for the proper architecture. The build command will output our new binary file into our original Filebeat directory from earlier. Finally, we can edit our filebeat.yml file with a couple important configuration changes. We tell Filebeat what IP our Kibana and Elasticsearch applications are running on, and also enable monitoring, which will be helpful down the line for troubleshooting and performance benchmarking of our Filebeat agent. The IP tables module is crucial for parsing and enriching the IP tables logs. Beat's modules are meant to supplement different log file types with things like Kibana dashboards, machine learning jobs, and Elasticsearch templates. In order to have the IP tables module enabled when Filebeat starts, we rename it to remove the .disabled from the end of the file. Then we edit the module configuration with the VI text editor. The IP tables module defaults to listening on syslog, but we want it to read a file, so we change the configuration as such. We also tell it what file on the Ubiquiti USG that it will need to read in order to harvest the logs. Now that we have compiled our Filebeat binary and made the necessary configuration changes, it is time to move the files over to our Ubiquiti Firewall by way of the scp-r command to recursively copy over all the files. After that, we can SSH into our firewall and move into the Filebeat directory. In order to set up Kibana for the IP tables logs, we run a one-time command and observe the output to confirm it was successful. From there, we can execute Filebeat and have it start reading the var log messages file and ship them on over into our Elastic stack. Moving back to the Kibana web interface, I view the monitoring statistics for the Elasticsearch cluster and observe that the indexing rate has jumped up, and so has the document count. I move to the Discover tab to view our Filebeat index and find all the logs that Filebeat is shipping over. The messages file contains a mix of IP tables logs and other logs, so don't be concerned if you see some extra log types in the Elasticsearch Filebeat index. From the Dashboards tab, I can search for the newly loaded dashboard and view the results. Be patient and adjust your time picker if you're not finding the logs, as they may not immediately show up. We can also view the monitoring statistics for the Filebeat agent, which indicates that the logs are being shipped. One of the latest and greatest features that has been added to Kibana is the Elastic SIM. This is a full-fledged SIM that provides the capability to correlate your network traffic with analytics from other log sources in your network, such as authentication and access logs, that might come from a Windows server. Getting to test drive the Elastic SIM was the primary driver for me to deploy Filebeat and the IP tables module. From the Dev Tools tab in Kibana, we can interact with the API to view the ingest pipeline that is parsing and enriching the IP tables firewall logs. There are ways to run Filebeat in the background and have it persist through a reboot, which I would encourage you to research on your own if you're finding this information useful. Have fun and happy hunting!